I think that exploring space is a cultural activity. It's been just science for science sake. And this is an important point for both the scientists and for the public to realize. When Armstrong stepped out on the moon, 100 million people watched him in real time, and the moon all of a sudden became a familiar place. When Mariners 4, 6, 7, and 9 photographed Mars, it was grasped away from science fiction and put into the role of science. And it was a real place, although very strange. It remains very strange. When Mariner 10 went to Mercury and photographed it for the first time, Mercury entered from the domain of obscurity, just nobody even knew it was there really, into at least a real place with features, with a surface, and a character of its own. As a consequence, in this last decade really, the volume of space that exists in the mind of men all over the world, millions and millions of men, has expanded.
Mercury, as seen through the best Earth telescope. Venus. In '62, these were the best photos of the planets we had. Mars. We had no knowledge of what features lay on their surfaces. We didn't know their ages. Had they formed at different times? The last 13 years has changed that. There's been a celebration of US and Soviet rockets to the planets. Beginning with the Russian mission to Venus in 1961, it accelerated to a crescendo in the spring of '74 when there were 6 rockets simultaneously traveling out from Earth. The planetary exploration was paralleled by Apollo, man on the moon. Apollo began from a political decision to get a man on the moon before the Russians did, specifically by 1970. They did that. Now, with the rationalization of hindsight, their trips to the moon have turned out to be the key to understanding the planets. The US National Aeronautics and Space Administration, NASA, has evolved 2 major scientific objectives for its research in space. 1, to seek out how life began. Secondly, to seek the origin of the solar system. The prime tools of planetary exploration are precision television cameras. These are 2 about to fly to Mars. They're made by craftsmen, each contributing something of his own design to the component he makes. Sculptors carving from solid lumps of metal. The cameras are on their last test before being fitted to the spacecraft. In a vacuum chamber, they're being checked to see their optics will not go out of focus in the temperature changes they'll experience when they're launched into space. They'll send their pictures back as a set of numbers, each number representing one of 256 possible levels of brightness. A computer converts each number to an appropriate dot of grey, and 500,000 dots build up a picture. A photograph can only show 10 shades of grey, so the numbers hold much more information than the picture you're looking at now. This picture can be reprocessed so as to reveal only the fine detail. These are some of the thousands of pictures from the mission to Mercury. With the arrival of the pictures, analysis begins. This machine compares two pictures of the same object taken at different times during a mission. It allows contours of a mountain to be plotted directly. The thousands of pictures are all individually studied and their information blended together in maps. NASA has created an information explosion. These maps are a complete contrast to the fuzzy blobs of 13 years ago. Then there were hundreds of theories of the origin, some saying the planets were the debris left after our sun had collided with other stars, some that the planets and sun condensed from a cloud of gas. The trouble was not finding a theory, but finding one which was not totally improbable. NASA's philosophy has been to visit as many planets as possible to find the facts, to find out what theory has to explain. What story of origin can we tell after 14 years of exploration? The search begins before men landed on the moon. The question then was, what was the cause of the craters there? Most people were sure they were volcanoes. But 15 years ago, in a field of volcanic craters in the Arizona desert, a study was begun. It was to prove this crater was not volcanic at all, that it was caused by the impact of a meteorite 24,000 years ago. The scientist who's made the most intensive study of meteor crater and the expert on impact events is Dr. David Roddy.
It's really quite surprising to me that as early as the mid-1950s, Meteor Crater was still considered to be a volcanic crater by a certain part of the scientific community. It's enough to blow your mind, but there were serious papers still being written at that time. But with the advent of the space program and the large amount of research that's been dumped into those kinds of areas, we've come to a point where we have enough physical data in which we can tell quite clearly the specific diagnostic criteria that tells us whether this is a volcanic crater or whether this is a meteorite impact crater.
The laboratory experiments that led to understanding what happened during an impact were done by Don Galt with this gun. It fires small aluminium spheres, they simulate meteorites, at speeds upwards of 20,000 miles an hour. The complexity of the gun is because the impact takes place in a vacuum. The angle of the gun can be varied. For the experiment we're about to see, it's a vertical impact into this box of sand. It's filmed with a high-speed camera, expanding 1 second into 5 minutes. Experiments and Roddy's fieldwork established how impact craters form, how they can be distinguished from volcanoes. It was Roddy who instructed the astronauts, and these are the actual diagrams he used. The meteorite would vaporize, and the floor of the basin would be flung into the air as large chunks of rock. The cone of surface material would flop over upside down, forming a raised rim, and the blocks of rock would rain back, creating an outer ring of secondary craters. The features were recognizable in the moon craters seen from Earth. So before man went to the moon, telescopes had confirmed that a few of those craters down there were caused by impact. The astronauts produced two very important results. The first was how many impacts the moon had received. In this dramatic piece of film, The lunar exploration module of Apollo 17 is just skimming over the tops of the lunar mountains on its last orbit before landing. On board, the last man on the moon, incidentally the only geologist to go there, Harrison Schmitt.
This bombardment was unbelievably intense. It's something that is almost beyond the comprehension of people, even geologists to a large degree. The surface of that moon, the light-colored surface you can see on a full moon, even now, was saturated with craters, with impacts capable of forming craters, say 100 kilometers in diameter. Saturated. Every point on that surface was hit with that size of an impact. After this time, after around 4 billion years ago, there was a period when there were a number of very large impacts large enough to form basins up to 1,000 kilometers in diameter. Now, this appears to be a very distinct and different period of bombardment. We don't understand why, but it is distinct.
The moon had been pulverized to a depth of 6 miles. The bombardment ended with impacts of an incredible size. The Imbrium almost split the moon in two. The second thing they did was to bring back rocks so that the events on the moon could be dated. The man who pioneered the chemical techniques necessary was Jerry Wasserberg.
Well, since we're mostly investigating extraterrestrial materials, and we have to worry about terrestrial contamination. In some cases, the total sample just weighs 1/millionth of a gram. So we have had to develop manipulative procedures and standards of cleanliness which permit us to handle these materials a single grain at a time, frequently much smaller than a grain of salt, and analyze that rather than our own droppings.
Wasserberg's team measure how long it is since a rock was last molten, since it solidified. Moon rocks are a mixture of the powdered remnants of earlier rocks, rocks that can be of such different ages that dating the whole sample would give meaningless numbers. That's why the natural cement is shattered so that some of the individual sand-like grains come free.
You can put it down.
Nothing in this laboratory is ordinary. That's not paper, but a very special plastic. The air is filtered. All surfaces covered with unchippable paint. Everything is wrapped till needed. Just those pieces which might be individual crystalline grains are sieved through, and finally they're picked out by hand. Each of the little grains is going to be dated from its content of lead, thorium, and uranium. The ratios of those 3 trace elements give the age since it solidified. Dissolved in acid, the grain goes into an ion exchange column that allows the chemicals through at different speeds. Experience tells them when the lead comes through. By catching just the right drip, he catches the millionth of a gram of lead he's looking for. That drop is gingerly put onto a heated wire. Gingerly, for to get that drop has taken 3 days' work. Finally, that wire is heated in a mass spectrometer, which flings the atoms down a tube where a magnet sorts them out and electronics count them. From here, it's arithmetic to calculate the ages. They're reaching back through long periods of time. 1,000 million years is given a technical name, 1 eon. The measurements show that all the material in the solar system is the same age, precisely 4.6 eons. The cratering began between this and 4 eons ago when it ended suddenly. The final big impacts were at 4 eons. Then came floods of lava rising from the interior of the moon. Since then, very little change at all. 10 or so craters like Copernicus and Tycho. This is what the moon would have looked like 4 eons ago, after the bombardment. Then the lavas flooded out. And since then, very little change apart from the dozen or so craters and the lavas changing to lighter grey. The next question was, is that bombardment something particular to the moon, or had it happened to the Earth as well? We couldn't know. Until recently, our oldest rock was from Minnesota. The oldest so far from Greenland. So we couldn't tell because on Earth we don't have rocks old enough to record the bombardment. So the question still was the cratering record special to the moon, or perhaps waiting to be read on the other planets? If it was, would it be the same story or a different one? The space missions were to answer that. But first, what's the scale of the solar system? Suppose the Sun to be 7 feet 6 inches across. At this scale, Mercury, a P. And it's 36 million miles from the Sun, 100 yards. Next planet, Venus, a walnut. It's 67 million miles, which is 190 yards. Earth and Moon, only 240 yards. Mars. 142 million miles becomes only 400 yards, a quarter of a mile. Massive Jupiter, a 9-inch cabbage. Now we move out to a different area of the solar system. 486 million miles are represented by 1,500 yards. From here on, distances are vast. Saturn would be at 1.5 miles. Uranus 3 miles, Neptune 4 miles, Pluto 7. 1971, the Mariner 9 spacecraft arriving to be launched to go into orbit around Mars and map it systematically. There'd been 3 previous flights to Mars, flyby missions. They'd seen moon-like craters as they zipped past, taking their strips of photographs. There were suggestions Mariner 9 should be cancelled. The answer was already known. Mars had craters. What was the point of looking at another moon? But they did go. In fact, it was to have been preceded by Mariner 8. A member of the TV team was Bruce Murray.
Mariner 9 was the geologist mission, and Mariner 8 was the meteorologist and the astronomer's mission. Except fate has a nasty way of interfering. Mariner 8 ended up in the Atlantic Ocean. There was a failure of the launch vehicle. And so these things have to be done very quickly because there's only a few weeks that one can launch at any particular opportunity to Mars. And we had to go with one space vehicle, Mariner 9, and had to somehow compromise the two. As it turned out, Mariner 9 proved to be an extraordinary exploration mission. I think it was the most astounding mission perhaps the United States has flown to date in many ways, because of the nature of the discoveries that were found. There's been a profound and I think irreversible cultural change brought about by the very act of space exploration and by having it well photographed. Means that the photographs could speak for themselves, not be interpreted through the jargon of science.
As Mariner 9 approached Mars, a tremendous dust storm broke out, covering the whole planet with dust 50 kilometers up into the air. As the spacecraft came in, all that the television team could see were these 4 dark spots, christened Groucho, Chico, Harpo, and Zeppo. Embarrassed and to fill in time, the team turned the cameras onto the 2 Martian satellites, Deimos the outer satellite, 10 miles in diameter, and Phobos, 20 miles across, both battered by billions of years in space. The storm lasted 30 days. Then, as the dust started to settle, the spots became darker and darker. There was mounting curiosity about what they could be. Then the Marx brothers' heads broke through. Immediately, two geologists, Mazersky and Macaulay, guessed they were volcano tops. The others were skeptical. When the dust did finally clear, there was no doubt. Groucho turned out to be the biggest volcano known in the solar system, 17 miles high, more than twice the height of Everest. Hal Mazersky, leader of the Mariner 9 TV team, now heads the committee selecting the site for the two Viking spacecraft that will land on Mars in 1976. Viking will search for life. It'll analyze the Martian soil for microbes and radio its answer back. Mazersky has to decide where they'll land and search.
What is the best place on Mars to land these very few spacecraft? We only have two. We've got a very complicated, very large planet, so we only have two chances to find the right information. The interesting thing about the volcanoes is that's where the atmosphere comes from, that's where water vapor comes from, that's the clue in the search for life. Well, that was our first requirement, that the planet be hot in the interior and the juice coming out of the volcanoes. The second problem is what happened to that water vapor after it came out. And we looked carefully at the pictures and we found that in this region there were a number of great stream channels that started in this country. They start in great masses of collapsed debris, and one of the ideas is that Mars warmed up and melted the subsurface ice, caused the collapse of the great masses of debris. Then the water flowed out downhill into the northern lowland. So our Viking landing site is obviously here, right at the mouth of these largest streams on Mars. In addition to the great conglomeration of channels that flows into the northern lowland, in other parts of Mars we have quite different kinds of channels. In this region, in the smooth uplands, is quite a different kind of stream channel. There are dozens of little tributaries that come together, and here it looks as though we have to have had water falling out of the Mars atmosphere and hitting the surface, collecting together into these little streams and flowing down this sinuous channel. All through the central upland of Mars, in every sloping surface, there are hundreds of little tiny microchannels, just a hundredth of the size of the ones we've been talking about. And this map was prepared for the Soviet Union. They tried to land on Mars earlier this year, and their landing site was right in the middle of this region that has dozens of these little tiny microchannels in it. They didn't successfully land. That was their fourth attempt. The lesson to us is that Mars is difficult to land on, so we really have to be prepared for our try in about a year and a half. What we found out from detailed examination of these three different kinds of channels is that some of them are very old. They have many craters that have struck them, and the sides are eroded and degraded. Others look brand spanking new and fresh. So we think that not only did the Mars climate have to have been different one time in order to form stream and have water flow on the surface, but it has to have been that way dozens of times in the past. Do I think that the most probable explanation of the stream channels is that water rained and flowed on the surface? The answer is yes. I think of the various choices we have, that's easily the best one.
A wind tunnel experiment at the University of Santa Clara, California. Ronald Greeley is trying to explain a unique feature on the Mars surface. He's looking for an explanation of a long black plume that stretches 60 miles. It obviously begins from a crater, and in the bottom of the crater he finds an intense dark spot. His theory is that this might be a volcanic source. so he set up in the wind tunnel a model crater into which he could introduce sand. He would let it drift downwind and film the pattern that would result. The plumes match. That suggests that there's at least one active volcano on Mars throwing its cinders across the surface. Jack Macaulay was senior geologist on the Mariner 9 team. He's been trying to understand this Martian feature, here dimly seen through the dust, but 40 days later seen to be two deep, rugged valleys. All the geologists were excited to see something familiar in the cliff edge, the big bite of a landslide, but dramatically bigger than any landslide on Earth. These cliffs are 4 miles high. This model of the canyons was made by NASA. Its accuracy has been approved by NASA's higher brass. This is what it would be like to swoop down into that vast canyon system. So deep, the Alps would get lost down there. Barely reaching halfway up the cliffs. It's called the Euphrates Canyon. It's 3,000 miles long. It's 150 miles wide. Macaulay believes it began from a fault crack. There are networks of cracks near the canyon. They're very similar to fault cracks on Earth, the result of tension pulling the surface apart. He believes that there was erosion of the exposed cliff faces. As here in the Arizona desert, this cliff is retreating as wind and water wear it away. To get some sense of scale, Euphrates is more than 100 times bigger than this, the Grand Canyon. The Grand Canyon, after its initial opening, is being widened by erosion. On Earth, the erosion is primarily by water, but helped by the wind. On Mars, the erosion is by wind alone, a fierce sandblasting by the thin wind at 400 miles an hour. One of the members of the TV team of Mariner 10 is a British scientist, Dr. John Guest.
It's interesting on Mars that the volcanoes tend to form some kind of a pattern. We have these 4 major volcanic structures running in this direction. They're in a straight line and must represent a fundamental structure in the Martian crust. And then we have this great Euphrates chasm running through here, another major structure in the crust. The planet is splitting apart there, forming a great tectonic fracture. Possibly the kind of thing that one could imagine if one was seeing incipient plate tectonics, where one plate is beginning to break away from another point.